Hey guys, welcome to lesson 85. Now this lesson, it's not complicated, but it is kind of long. So I want you to open up to lesson 85, page 303 in your book, and follow along with me. I'm going to be reading a lot of the lesson just to help us stay on track with the points. So it says, we remember that the graph of a vertical line is everywhere equidistant from the y-axis. So when your line is up and down, vertical line, that means that all the points are the same distance from this y-axis. For example, you can see this vertical line here. All the points on it are 3 over from the y-axis. In the figure on the left below, so if you look at your book, it's the box on the left below, every point on line A is 3 units to the left of the y-axis, and the equation of the vertical line is x equals 3. So that's this one here on my board. All of the points are 3 to the left of the y-axis. Then every point for B, that would be this one right here, they are 5 units to the right. So you count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're all 5 units to the right. And the equation is x equals 5. So if the equation of every vertical line has this form of x equals something, then we can put that in the form of x equals plus or minus k. So it's positive or negative k. So a vertical line is x equals then whatever number you have, positive or negative. Okay? It's the same thing with a horizontal line, except this time it's y equals. So if you look at equation C, y equals 2, you see that every point is 2 units above the x-axis. So remember, this is our y-axis, this is our x-axis. So y equals 2, every single point is 2 units above. Y equals negative 4, every point is 4 units below. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So y equals negative 4. So that shows us that for a horizontal line, it always has this form. Y equals positive or negative k. So a horizontal line is just y equals something. Okay? So we see that the equations of vertical and horizontal lines can be determined by inspection, meaning you just look at them and you can figure out what the equation is. For example, I can just look at this one and see that it's 1, 2. Every point is at 2. So that means no matter what x is, y equals 2. This one here, I can see that every point is at negative 3. So no matter what y is, x equals negative 3. So you can easily figure out that equation. Well, we can do this even if our line is not horizontal or vertical. We can figure out what the equation should be. The equation of a line that's neither vertical nor horizontal cannot be determined by inspection exactly the same way. However, the equations of these lines can be written in what we call slope-intercept form. The following equations are equations of 3 different lines written in slope-intercept form. So look in the middle of page 304 to see the equations that I am referring to. Equation A, negative 6x plus 2. Y equals negative 6x plus 2, excuse me. Equation B, y equals 2/3 x minus 5. Equation C, y equals 0.007x plus 3. So you should notice something about each of those equations. We note that each equation contains an equal sign, a y, an x, and 2 numbers. The only difference in the equations is that the numbers are different. So we use the letters m and b when we write this equation without specifying the 2 numbers. So we have this form, y equals mx plus b. So m and b are the 2 numbers, but we always have y and x. So y equals, and there's something times x, and then there's added b. By the way, that can be negative because that's the same as adding a negative. okay? Subtracting b is the same as adding a negative b. So since the equation of any line that is not vertical or horizontal can be written in this form, the problem of finding the equation of a given line is reduced to the problem of finding the two numbers, which will be the values of m and b in the equation. So we're going to start looking at that right now. Okay, so the first thing that we're going to talk about finding in the equation of our line is the intercept. Now remember that I call this equation y equals mx plus b slope-intercept form. So m is the slope, and we'll talk about that next. B is the y-intercept. So let's talk about that. We call the constant b the intercept because the b represents the value of y when x has a value of 0. So when we haven't gone anywhere with x, so we are on the y-axis. So it's where our line intercepts or crosses over our y-axis, okay? So thus b is the y-coordinate of the line at the point where the line intercepts the y-axis. So let's look at these two equations that I have here to see their intercept. So you see this line right here. Well, where does it intercept my y-axis? Well, it's here at 1, 2, 3, 4. So it's at the point 0, 4. So in my equation, y equals negative third x, positive 4 is the intercept. Okay, let's look at this equation down here. I have 0, negative 3 is where I intercept with the y. Negative 1, negative 2, negative 3 for this line. So my slope here, y equals 1/2 x minus 3, because, or excuse me, my intercept is a negative 3. So b is negative 3. Okay, that one's super simple, right? Well, now let's talk about slope. This is simple, but this is where sometimes people get a little bit like, what are you talking about? So in the slope-intercept form, y equals mx plus b, we call the constant m the slope of the line. When you hear the word slope, think of a hill. Think of going up or going down. That's your slope. In the equation, negative 2x plus 6, we say that the slope of this line is negative 2 because the coefficient of x is negative 2. We note that the slope has both a sign and a magnitude, an absolute value. So the sign is positive or negative. The magnitude is the absolute value. So the distance from whatever our lines are. A line represented by a line segment that has points toward the upper right part of the coordinate plane has a positive slope. A line represented by a segment that points down toward the lower right part of the coordinate plane has a negative slope. A mnemonic to help us remember this, we will use the little man in his car. He always comes from the left side, as shown here. So you should be looking in the middle of page 305, in case you're not. I want to make sure you see this. So the guy in the car always comes from the left. If he goes up, then it's a positive slope. If he's going down from the left, it's a negative slope. Okay? So that's just what helps us to remember. So coming in from the left, if he's going up, positive slope. If he's going down, negative slope. And you can see that here. In this line, my slope is negative 1/3. And you see it's going down. In this line, you see my slope is positive 1/2. It's going up. Okay? Well, how do I find this? The magnitude or absolute value of the slope, so just the value of the slope itself without worrying about the positive or negative, is defined to be the ratio of the absolute value of the change in the y-coordinate over the change in the x-coordinate as we move from one point on the line to another point on the line. Okay? So I want to look at these two lines that I already have on my board. We already have the equations written on my board, but I want you to see how we got those slopes. So for the first one, here are 2 points. So to find m, the absolute value of m, I have to first look at the change in y from one point to the next, and then the change in x. So I see this point, my starting point is 4. 4 up. 4 is my y. So looking at my fraction here, 4 is my y. Then the next point, 3 is my y. Okay, see, I'm 1, 2, 3 up. So my change is 4 minus 3. Okay? Then I need to look at my change in x. So my first x here is 0. My second x here is 3. So the absolute value of my slope is 4 minus 3 over 0 minus 3. And that equals, 4 minus 3 is 1, its absolute value is 1. 0 minus 3, its absolute value, well, 0 minus 3 is negative 3, and its absolute value would just be 3. And we see, since we're going down, it is a negative 1/3. So when we are finding the slope, we don't have to worry about using the absolute value. We just find the slope by finding the change in y over the change in x. Now there's a shortcut for how you would write this formula. We call it rise over run. Okay, the change in y is the rise, how far up and down you go from one point to the next. So your rise, and then your run is your change in x, because it's like you're running to the next point. So your rise, how far up or down you go, over your run, how far over you go. So I can do that kind of backwards. You see how this makes a triangle? So let's look at this one. Let's say I wanted to know my slope for this one. I have my rise, how far up I go, over my run, how far over I go. So my rise from one point to the next. Well, I have, let me do it this way, excuse me guys. My first point is at negative 2y, so I have negative 2. My second point is at negative 1. That's how far up I went, was to negative 1. So minus a negative 1. Over, my run is that I started at 2. Okay, so this point is at x equals 2. Minus, well, my next point is at 4. Okay, so now I subtract. Negative 2 minus a negative 1. That's the same as negative 2 plus 1. That would be negative 1. And negative 1 over 2 minus 4. That would be 2 plus a negative 4, which gives me a negative 2. When I have a negative divided by a negative, that equals a positive. So I have a positive 1/2. Okay? So that's my slope. Did you get confused at all? Okay, I hope not. Let's keep looking, okay? So we've labeled the change in x as the run and the change in y as the rise. We've looked at that. Using these words, the magnitude of the slope can be defined as the absolute value of the rise over the absolute value of the run. But we don't need to really worry about doing the absolute value. You can just find it as is, okay? But to just give yourselves a little bit of a hint, a little bit of a mental check, if it's going up from the left, then you know you should have a positive slope. If it's going down from the left, you know you should have a negative slope. And if you don't, that means you've done something wrong, okay? So let's see. The general form of the equation of a line is y equals mx plus b. And to write the equation of the line, we need to know, first of all, the value of the intercept b, the sign of the slope, and the magnitude or absolute value of the slope. We see that 1, the y value of the coordinate of, So for, I'm not sure which equation they're looking at, guys, I'm sorry. Okay, they're looking at a different equation, so we're not going to continue with that one. Okay, I want you to look at example 85.1, but we're going to look at that in the second half of this video.